Hello all, a very good day to all of you. In this session, we will discuss all the questions that have come from analog circuits in 2017 set to get examination for electrical engineering branch. Okay, so in 2017, right, for set 2, there were total 3 questions that is of 2 marks, right, that have come from this subject. Okay, so in total 6 marks have been asked from this subject. Okay, so let us discuss all the question one by one. The first question is, in the circuit shown in the figure below, right, it is given that VCE is nothing but drop from collector to emitter is VCC by 2 is equal to here 5 volt, because VCC 10 volt, so it is 5 volt. Okay, transistor have a beta of 29. What is beta? The beta is nothing but the collector current divided by my base current, given 29. So this is my collector current IC, this is my base current, right? IC, this is my base current. Okay, and VB is equal to 0.7. Drop from base to emitter is 0.7 when the base to emitter junction is forward biased, right? So with this conditions, we need to find out the value of the ratio of RB by R. Okay, so I think it's an easy question. Let us solve it. Okay, see, the current through collector is nothing but given by IC. The current through resistor RB is nothing but IB, and this current is IE. Okay, is equal to IC plus IB. Okay, and since both IB and IC is flowing through 4R, so the current through 4R will be IC plus IB. Okay, now simply we'll put 2 KVL. The first one is through this one, through the outer loop. Okay, so let's put the KVL. KVL 1. Okay, 10 volt minus 4R into the current is IC plus IB minus VC, right, minus IE nothing but IC plus IB into the resistance is R. Okay, this is equal to 0, right? Simplest VC is nothing but given 5 volt, right? So 10 minus 5 is 5 volt minus 4R plus R is nothing but 5R into IC plus IB is equal to 0, right? So this implies 5 into R into IC plus IB is equal to 5, right? So you know, since drop across collector to emitter VC is VCC by 2, definitely the drop across 4R plus R will be 5R into IC plus IB is equal to 5 volt. Okay, so let this be the first equation, right? So the simplest also I also can do a simplification, right? It will be R into IC plus IB is equal to 5 get cancelled, it is equal to 1. Okay, this is the loop 1, so I can say this is equation 2. Okay, now put a second loop in the, okay, we'll put a second KVL through this path. Okay, so if I put the KVL, right, the current here is IC plus IB, here is IC, here is IB, here is IC plus IB, right? The same current is flowing through the emitter, right? So let's put the KVL here. Is equal to 10 minus 4R into IC plus IB, right? Minus RB into IB, right? IB into RB minus VB minus VB minus I into R. I means IC plus IB minus IC plus IB into R is equal to 0. Okay. This implies 10 minus 4R into IC plus IB minus R into IC plus IB is equal to 5 into R into IC plus IB, right? Minus RB into IB minus VB is nothing but 0.7. Okay, equal to 0. So from the equation 1, 5 into R plus IC plus IB is equal to 5 volt only, right? So this I can replace by 5 volt. So it's equal to 10 minus 5 is 5 minus RB into IB minus 0.7 is equal to 0, right? This implies IB into RB equal to 5 minus 0.7 is 4.7 volt. So this is equal to equation 3, right? Now, if I divide equation 3 by equation, suppose 2, okay, divide 3 by 2, So here IB into RB, in equation 2 it is R into IC plus IB equal to R into IC plus IB, okay, is equal to 4.77 divided by, this is 1, right? This is 1 by 1. Simplifies IB into RB, right, divided by R into, what is IC? IC is nothing but beta into IB, right? So I can calculate, common take beta IB plus IB is equal to 4.7. This implies if I take IB common, right? So IB get cancelled. I will get RB by R into beta plus 1 equal to 4.7, right? So this implies RB by R equal to 4.7 into beta plus 1. This implies is equal to 4.7 into 30. Okay, so let's do the calculation. 4.7 into 30 equal to 141. Sorry, there is some mistake in somewhere. So I got 2.3, 4.3 and 30. So it is 4.3, right? Because I think 5 minus 0.7 is 4.3, not 4.7. Right? This is 4.3. This is also equal to 4.3. This is equal to 4.3. So here also 4.3. Here also 4.3. So answer is equal to 129. Okay. So here you see 5 minus 0.7. I put 4.7. It's wrong. Okay. Should put 4.3 only. Right. So it's easy question. So answer should be 0.129. Okay. 129. So let me change the color. Okay. So just to put one loop in the outer side, another loop in the inner. Then if you solve this two equation, I can easily get RB by R. Okay. Let us see the next question. For the circuit shown in the figure below, right? Assume that the op-amp is ideal, meaning is that the gain of the op-amp is equal to infinity, the input impedance is equal to infinity, bandwidth equal to infinity, and the output resistance equal to 0. Right? Now you see in this circuit given, we have to find out the link or relationship between V0 and Vs. Right? We have to find out the link between V0 and Vs, or I can say the relationship between V0 and Vs. Okay, so let us solve this question. We know since the output is getting fed back to the inverting terminal, so the op-amp is operating in negative feedback. Okay, so whenever an op-amp is operating in negative feedback, we know the potential at the positive terminal equal to potential at the negative terminal. Okay, since here you see the Vs is coming and exactly divided by 2, because Vs, the V positive is equal to Vs into 2R divided by 2R plus 2R is equal to Vs by 2, right? So because the Vs is exactly having a resistive divider having same value, so here we will get Vs by 2. Okay, and since B positive is B negative, it is equal to Vs by 2. Okay, so here I got Vs by 2, right? So now let us put a nodal equation at the negative terminal. Okay, so let us put a nodal at negative terminal. Okay, so this potential here is V negative by R plus, suppose this is Vx. Okay, V negative minus Vx by R, right? V negative by R plus V negative minus Vx by R equal to 0. Okay, this implies what is V negative? V negative, so this implies V negative plus V negative minus Vx is equal to 0. Okay, this implies Vx is equal to 2 into V negative. 2 into what is V negative is nothing but Vs by 2. Vs by 2 equal to how much? Vs. Okay, so Vx is equal to Vs. Now let us put a nodal at the point X. Okay, let's do a next page. Okay, so nodal at X. Okay, so this is V negative. Vx minus V negative. Okay, divided by R plus Vx minus V0 by R plus Vx by R. See, this current, this current, and this current. This current is nothing but Vx minus V minus by R. This current is Vx minus V0 by R plus Vx by R is equal to 0. Okay. So R will go to the side and it will go to cancel. So Vx plus Vx plus Vx is equal to 3Vx minus V minus, right, minus V0 is equal to 0. Simplest V0 is equal to 3Vx, right, minus V minus. Okay, 3 into what is Vx to calculated is Vs only, right? Vs minus what is V negative? V negative is Vs by 2. Vs by 2. Okay, simplest 3 minus 1 by 2 into Vs. Okay, so is equal to 2.5. Vs is equal to V0. Okay, this is the answer. Answer is this one. Okay, simply you have to know two things. First thing is virtual ground principle. Okay, that makes V negative is equal to V positive. Second thing is we put a nodal at negative terminal, then we put a nodal at the point X. So then if you solve these two equations, I can easily get the output in terms of source voltage Vs. Okay, let us show you the next question. In the circuit shown in the figure below, okay, the diode is used as a ideal diode. Okay, the input power factor we have to find out. Okay, so first thing is what is input power factor? Input power factor is equal to input power factor is equal to, okay, V output RMS into I output RMS divided by V input RMS into I input RMS. Okay, this is the formula for input power factor. Okay, so in this, what you have to do? You have to find out V output RMS, I output RMS, and I input RMS and V input RMS. Okay, so then how to do? You see, in this circuit, right? During positive half cycle, right? Diode will be like a short circuit, right? Because diode will be forward biased, right? So it will be like a short circuit. So my V output will be V input. Totally will come to my output. Okay, 100 volt. During negative half cycle, right? The diode will be open, so my output will be 0. Okay, again the same thing will repeat. Okay, so I got at the output a half wave, is a half wave sinusoid output, sinusoid. Okay, and thing is half wave sine wave. Okay, and thing is whenever forward bias is there, right, the current will flow, and whenever the diode is reverse bias, there is no current. Okay, and since the input and output connected in series through this diode, so the output RMS is equal to input RMS, because whenever the current will flow, it will flow through the diode to the output, right? So the output RMS is equal to input RMS. So the power factor is equal to input power factor is equal to V out RMS divided by V in RMS, right? Because since the current will flow through, there is only one branch, the same current will flow through input and the output. So the RMS of the output will be equal to RMS of the input. Okay, and we know the output is a half wave sinusoid of the input. So for a half wave sinusoid, we know the RMS value will be equal to Vm by 2, right? Similarly, for the input, it's a pure sinusoid, the RMS will be Vm by root 2. Okay, so the input power factor will be root 2 by 2 equal to 1 by root 2. Okay, so let us calculate 1 root 2. We got 0.707. Okay, so the answer should be 0.707. Okay, so I think that's all. Thank you guys.